All right, so this is a key to test 4, and in number 1, it says solve the following equation by factoring. All right, so we're going to factor this. We need to put this in standard form. We need 0 on this other side. So let's go ahead and rewrite this as 6x squared plus 7x minus 3 equals 0. All right, so notice the GCF here is 1, so I'm going to go ahead and do this. Factor this as two binomials. And so the possibility that it works is going to be 3x and then 2x. And then for negative 3, let's make this a negative 1 and this a positive 3. So always make sure you double check before you go 1. So notice when you FOIL, 3x times 2x is 6x squared. The outer is 9x. The inner is a negative 2x, and you get that 7x. And then the last, a negative 1 times 3 is a negative 3. So now you're going to use the zero factor property. And so I'm going to set each of those factors equal to 0. And so there's the work you had to do. You had to show all this work. And so now you went from a quadratic equation to two linear equations. So I'm going to add 1 to both sides. So I got 3x to be positive 1. That's a positive 1. Then divide both sides by 3. 3 divided by 3 is 1, so I got x to be 1/3. So there's one of your solutions. The other one, if I subtract 3 from both sides, I get 2x equals negative 3. Divide both sides by 2. I get x to be negative 3/2. So those are your two solutions. All right, so there's the work. That's the work you had to do. All right, and there's your answer. All right, in number 2, you want to simplify the rational expression. Let me go ahead and rewrite this better. So my rational expression is x squared minus 5x plus 6 divided by x squared plus 2x minus 15. So in simplifying a rational expression, you want to first of all make sure you factor the numerator and factor the denominator if possible. And both of those are factorable. So when I factor this, I'm going to get x minus 3 times x minus 2 is the numerator. The denominator is going to be x minus 3 times x plus 5. Okay? And now the next step you have to do is to reduce. So once you factor, you got to reduce, and you got to show what's being reduced. So notice that x minus 3 are common factors. So when you divide x minus 3 by x minus 3, you get that 1. So you're left with factors of 1s in their place. And so now the answer is going to be 1 times x minus 2 is x minus 2, and then 1 times x plus 5 is x plus 5. So there's your answer, and then there's your work. Okay? All right, number 3, you want to divide these two rational expressions. So let me go ahead and rewrite this better so you can see this. So this x squared minus 5x minus 6 divided by 5x plus 15 divided by, and then this rational expression is x squared minus 3x minus 4 divided by 7x plus 21. First thing I'm going to do is change this division to multiplication. So this becomes x squared minus 5x minus 6 divided by 5x plus 15. So remember when changing division multiplication, you're going to multiply by the reciprocal. So the reciprocal of the fraction following the division symbol. So it'll be 7x plus 21 divided by x squared minus 3x minus 4. Okay, then we're going to, I'm going to go ahead and write this here. Then we're going to factor, just like we did here. You're going to factor all the numerators, all the denominators if possible. And in all of these, you can factor. So in the first one, I can factor this as two binomials. So I get x minus 6 times x plus 1. The denominator I can factor out of 5. The GCF here is 5. So it's 5 times x plus 3. Times, in the numerator, I can factor out a 7. GCF is 7. So 7 times x plus 3. Divided by, and then in the denominator, I can factor that as x minus 4 times x plus 1. Okay, now the next thing you're going to do is reduce. So x minus 6 is the first factor I see in the numerator. I don't see any in the denominator. The next one's x plus 1. That reduces with this one. I see 1 here, so those divide out. Remember, factors of 1s in their place. The next factor is a 7. I don't see any factors that 7 will reduce into. The next factor is x plus 3. I see 1 here, so those divide out, and then that's it. That's all I can reduce. So now I get x minus 6 times 1 times 7 times 1, so that becomes 7 times x minus 6. That's your numerator. Divided by 5 times 1 times x minus 4 times 1, which is 5 times x minus 4. And so there's the answer there. Okay, so there's your work. There's the work, and there's your answer. Okay, number 4. Okay, number 4, you want to add these two rational expressions. Okay, now there are a couple of approaches you could have taken. So you can attempt to, let me go ahead and rewrite this. So that's x squared plus x minus 12 divided by x squared minus 4x plus 3 plus 2 divided by x minus 1. Okay, so remember when adding or subtracting rational expressions, you want to make sure you get that common denominator. So that least common denominator. So you're going to have to factor the denominator here. Now in the process, let's go ahead and factor this and see what happens. So if I factor the numerator, I get x plus 4 times x minus 3, right? If I factor the denominator, I get x minus 3 times x plus 1, it looks like. Okay? Well, I'm sorry, x minus 1, excuse me, x minus 1. All right, x minus 1. Now, I want you to notice that these two factors divide out, correct? And don't forget you have plus 2 divided by x minus 1. So by doing it this way, I notice that these two factors divide out, and so what I have is this. I have x plus 4 times 1 is x plus 4, divided by 1 times x minus 1 is x minus 1, plus 2 divided by x minus 1. Right away, the denominators are the same. So now all I need to do is write this as one rational expression with that denominator. And then x plus 4 plus 2, 4 plus 2 is 6. That becomes x plus 6 divided by x minus 1. So there's the answer. Now another approach, let me go ahead and use another sheet of paper. Another approach is this. So this is x squared plus x minus 12 divided by x squared minus 4x plus 3 plus 2 divided by x minus 1. All right, so let's suppose that you did not factor the denominator, but you had to factor let's suppose you did not factor the numerator, but you had to factor the denominator. So that denominator I can factor as x minus 4, x minus 3 times x minus 1. So the LCD is x minus 3 times x minus 1. So now what I'm going to do is I'm going to write two fractions with that denominator, two equivalent fractions with that denominator, with that LCD as your denominator. So that's x minus 3 times x minus 1, x minus 3 times x minus 1. I want you to notice that this denominator is the same as this. So in terms of equivalent fractions, this numerator has to be the same as this one. So x squared plus x minus 12. Now over here, I have an x minus 1, but this is what I want. So I've got to multiply this both numerator and denominator here by x minus 3, right? X minus 3. So that becomes 2 times x minus 3. So now notice that the denominators are the same. So I'm going to rewrite this as one rational expression with that denominator. And so I get x squared plus x minus 12. Plus, and then distributing here, I get 2x minus 6. 2x minus 6. Now, combining like terms in the numerator, I get x squared. X plus 2x is 3x. A negative 12 and a negative 6 is a negative 18, divided by x minus 3 times x minus 1. Factoring that numerator, and it's factorable, that's a minus 18 right here. It's factorable. I can factor that as x, let's see, that's going to be x plus 6 times x minus 3. And the denominator, I get x minus 3 times x minus 1. And then notice that these x minus 3's divide out, and you're left with x plus 6 divided by x minus 1, which is the same answer you had. Let me see if I can find that problem, which is the same answer you had here. Okay? All right, so two approaches in this particular case you could have done. So factoring numerator and denominator first, you notice that these factors can reduce and it makes it simpler. That's not always the case. It doesn't always work that way, but in this case it did. And then here, if you forgot to factor the numerator, then this is what you would have had to end up doing. All right, so that was number 4. Okay, the other approach, number 4. Let's look at number 5. Number 5, you have this complex fraction. So let me go ahead and rewrite this over. You have 2 plus 4 divided by x minus 2 divided by 2 divided by x minus 2. Now, notice that I'm going to, this 2 right here, I can write as 2 over 1. And probably the easiest way to do this is to go ahead and multiply both numerator, and we're going to use um, the second approach. So we're going to multiply both numerator and the denominator by x minus 2. So my LCD is x minus 2. So here's what I'm going to have. I'm going to have times x minus 2 times x minus 2. Okay? Now I'm going to distribute the x minus 2 here. So I get 2 over 1 times x minus 2 plus 4 divided by x minus 2 times x minus 2 divided by 2 over x minus 2 times x minus 2. So all of these fractions are multiplied by x minus 2. And now what ends up is in the numerator, if you look at that numerator right here, I have 2 times x minus 2, but you got to put that in parentheses, so be careful. So this x minus 2 has been multiplied by 2 every term. So you need parentheses right here. And then over here, these divide out, right? So that's just plus 4. Divided by, and over here, these divide out, so that's just 2. So now if I distribute the 2, I get 2x minus 4 plus 4 divided by 2. A negative 4 plus 4 is 0, so that becomes 2x divided by 2. And then the 2's divide out, and you get x. And so there's the answer. There's the work. There's your answer. Okay? All right, number 6. All right, so number 6, you want to solve this equation, and so notice it's already factored. Everything's already factored. So you're going to find the LCD. So the LCD is going to be x minus 2x plus 2. Okay, and the way we're going to do this is we're going to multiply both sides by the least common denominator. Now, before we do that, let's talk about those restrictions. So your restrictions. So what makes this denominator 0? X minus 2 is 0 and x is 2, so I cannot use 2. Over here, x plus 2 is 0 and x is negative 2, so those are your restrictions. And then over here, x minus 2 is the same as this one, so that's already taken care of. And over here, x plus 2, it makes that 0, is negative 2. So there's only 2 restrictions here. But what I'm going to do is I'm going to multiply both sides by that least common denominator. So it has minus 2, x plus 2, times the left side, which is x plus 3, divided by x minus 2, minus 14 divided by x plus 2, equal, and then x minus 2, x plus 2, times the right side, 3x minus 2, divided by x minus 2, times x plus 2. Okay? Then I'm going to distribute, so I get x minus 2 times x plus 2 times the first fraction, x plus 3 divided by x minus 2, minus, and then this times this, so x minus 2, the LCD, x minus 2, x plus 2, times that second fraction. Now I'm running out of room here, so I'm going to go ahead and divide these out. So these factors divide out with the factors in the denominator. So you're left with 1 times 3x minus 2, which is 3x minus 2. Now remember, the whole purpose of multiplying by the LCD is to clear those denominators. So let's go ahead and clear these. The x minus 2's divide out. The x plus 2's divide out. Now be careful over here. You have 1 times this binomial times this binomial. So I'm going to rewrite this as x plus 2 times x plus 3. Minus, and then that's 14 times x minus 2, because that's a 1. So 14 times 1 is 14 times x minus 2. This is what it should look like. Equal, and then 3x minus 2. Alright, so now going ahead and foiling this out, because you have two binomials here, you get x squared plus 5x plus 6. Distributing over here, you get minus 14x plus 28. Negative 14, negative 2 is positive 28, equal 3x minus 2. Combining like terms, I get x squared, 5x, and a negative 14x is a negative 9x. 6 and 28 is a positive 34, equal 3x minus 2. Alright, so notice I have this quadratic equation, so I'm going to bring all the terms to one side. So let me go ahead and subtract 3x from both sides. And so when I do that, I get x squared minus 12x plus 34 equal 0 to negative 2 is negative 2. Adding 2 to both sides, I get x squared minus 12x plus 36 equal 0. Now let's go ahead and factor this. If I factor this, it becomes x minus 6 times x minus 6, right? So these are the same factors. So all I need to do is just use one of those factors, set equal to 0. So I get the solution to be 6. Now that's my proposed solution. So remember, you need to check your restrictions. So 6 is not one of these. So that is your solution. So this proposed solution is your solution. Okay, so that's number 6. Okay, number 7. It says assume all variables represent positive numbers, and you want to simplify, and I'm going to go ahead and rewrite this over. So you want to simplify the cube root of 8x to the 15th y to the 24th. Now remember, the product property says I can rewrite this as a cube root of 8 times a cube root of x to the 15th times a cube root of y to the 24th, right? And the cube root of 8 is 2, so that's easy. I can simplify the cube root of x to the 15th because 15 is greater than or equal to 3, and this is an easy one because 15 is divisible by 3. So the cube root of x to the 15th, 15 divided by 3 is 5, so that's x to the 5th. Kind of makes sense because if I take x to the 5th, multiply by itself 3 times, I get x to the 15th. Same thing here. That's an easy one. 24 divided by 3 is 8, so that becomes y to the 8th. So that's the answer to part 1. Part 2, same idea. You're going to rewrite, let me go ahead and show you what this says. This says the fourth root of a to the 20th power b to the 12th. So according to the product property for radicals, I can rewrite this as the fourth root of a to the 20th times the fourth root of b to the 12th. And I can simplify each one of these because the exponent is greater than or equal to the index. These are easy because the exponent is divisible by the index. So 20 divided by 4 is 5. So the fourth root of a to the 20th, so what times itself 4 times is a to the 20th, and that's a to the 5th. Over here, 12 divided by 4 is 3, so that's b to the 3rd. So there's the answer to that one. So that's part 2. Okay, in problem 8, there are 3 parts here, and you want to simplify each of those. So assume all variables represent positive numbers. So I have a square root of x cubed y to the 6 times a square root of x y squared. So I can write this as one square root just by multiplying the radicands. So since the indices are the same, when you multiply, you just multiply the radicands together. But remember, x cubed times x is x to the 4th. So 3 plus 1 is 4. When you multiply like bases, you add exponents. Y to the 6th times y squared is y to the 8th. 6 plus 2 is 8. And now, just like we did here, I can rewrite this as the square root of x to the 4th times the square root of y to the 8th, and then simplify each part. The square root of x to the 4th, what times itself twice is x to the 4th? Well, that's x squared. 4 divided by 2 is 2. What times itself twice? The index is 2, so what times itself twice is y to the 8th, and so that will be y to the 4th. 8 divided by 2 is 4. So that's that one. Now in this one, you want to use the quotient property first. So the way I would do this, let me go ahead and write this over. You have the square root of 32x to the 7th divided by the square root of 2x. So I'm going to write this as one square root. So the square root of the numerator, 32, x to the 7th, divided by 2x. And then 32 divided by 2 is 16. So it becomes the square root of 16. And then x to the 7th divided by x. When you divide like bases, you subtract exponents. 7 subtract 1 is 6. So it becomes x to the 6. And then kind of using this idea here, I get the square root of 16 times the square root of x to the 6. The square root of 16 is 4. And the square root of x to the 6, 6 divided by 2 is 3. So I get 4x cubed. Over here, so in part 3, you have 5 times the square root of 32. So let's talk about 32 first. So you notice that the largest perfect square that goes into 32 is 16. So I can rewrite this as the square root of 16 times the square root of 2. So that is the square root of 32. And the square root of 16 is 4, so you get 5 times 4, square root of 2. And then 5 times 4 is 20, so you get 20 square root of 2. All right. Okay, in number 9, you have You want to simplify these square roots. But notice when we did these were easy problems here because the exponent was divisible by the index. Same thing here, 20 divided by 4, 12 is divisible by 4. Here, though, that's not always going to be the case, so you got to remember what we talked about. So let's get to part 1 first. So in part 1, I have the square root of x to the 10th times the square root of y to the 7th, right? And so this one's easy because 10 is divisible by 2, so that's the easy kind here. So I'm just going to leave it like the square root of x to the 10th for right now. Now, I can simplify the square root of y to the 7th because the exponent is greater than or equal to the index 2. But 7 is not divisible by 2, so you want to think about how you're going to rewrite this. So what's the largest whole number less than 7 that's divisible by 2? And so that will be 6. So you can say the square root of y to the 6th times the square root of y, right? 6 plus 1 is 7. And now notice I can simplify this easily, I can simplify this easily, and I cannot simplify this because the index is 1 and 1 is less than the exponent is 1 and 1 is less than the index, which is 2. So this becomes x to the 5th, y to the 3rd, 6 divided by 2 is 3, times the square root of y. So that's the answer to part 1. In part 2, the same idea. So you're going to say the square root of 12 times the square root of x to the 15th times the square root of y to the 14th. And you're going to use that same approach. The largest perfect square that goes into 12 is 4, so this becomes the square root of 4, square root of 3. 15 is not divisible by 2, so let's think about those just like we did this one. What is the largest whole number less than 15 that's divisible by 2? You can say 14. So it'll be the square root of x to the 14th times the square root of x. 14 plus 1 is 15. And then here, 14 is divisible by 2, so I'm going to leave that as it is. And now we can simplify this, we can simplify this, and we can simplify this. Square root of 4 is 2 times the square root of 3. Square root of x to the 14th. What times itself twice is x to the 14th? Well, it'll be x to the 7th. 14 divided by 2 is 7 times the square root of x. And then 14 divided by 2 is 7 as well. So that's y to the 7th. Now remember, though, you want to rewrite that square root of 3 times the square root of x as one square root. Since the indices are the same, they're both square roots, you can write this as one square root. So the answer is going to be 2 x to the 7th, y to the 7th, times the square root of 3x. Just multiply the radic hands together. All right, so that was number 9. Okay, number 10. So this time it says work is required this time. So in part 1, we're going to do part 1 right here. In part 1, we have the cube root of 16 x to the 10th, y to the 7th. So using a product property for radicals, I can write this as a cube root of 16 times the cube root of x to the 10th times the cube root of y to the 7th. Now, this one's easy because the cube root of 16 is 2. 2 times, the cube root of the largest perfect cube, the largest perfect cube that goes into 16 is 8. So we got to rewrite this. So it'll be the cube root of 8 times the cube root of 2, right? 8 times 2 is 16. Okay, now 10 is not divisible by 3. So just like we talked about, what's the largest whole number less than 10 that's divisible by 3? And that's 9. So the cube root of x to the 9th times the cube root of x. 9 plus 1 is 10. Same thing here. The largest whole number less than 7 is divisible by 3 is 6. So it'll be the cube root of y to the 6th times the cube root of y. Now we can simplify this one. So this is easy to simplify. This is easy to simplify. This is easy to simplify. The others I cannot simplify. I cannot simplify this one because the exponent 1 is less than the index. Same reason here. Okay, so now I get the cube root of 8 is 2 times the cube root of 2. The cube root of x to the 9th is x cubed times the cube root of x. The cube root of y to the 6th is y squared times the cube root of y. And I'm going to put all these right here together, and then I'm going to write this as one cube root. When you multiply radicals with the same index, you can write as one radical. So I get 2x cubed y um, squared. Make sure I didn't make a mistake here. Let's see. Um, yeah, so that's correct. Y squared. And then the cube root of 2 times the cube root of x times the cube root of y is the cube root of 2xy. And so that's the answer to part 1. Okay? Part 2. Okay, part 2. We have 3 times the fourth root. I'm just going to rewrite this over. 3 times the fourth root is 16, x to the 12th, y to the 15th. So we're going to use the same approach we used here. So I get 3 times the fourth root is 16 times the fourth root of x to the 12th times the fourth root of y to the 15th. Okay, now the fourth root of 16 is 2 because 2 times itself 4 times is 16. So that's 2. So this is 3 times 2 right here. I can simplify very easily, I can simplify the fourth root of x to the 12th because 12 is divisible by 4. So that's 3, right? X to the third power. X to the third times itself 4 times is x to the 12th. Now over here, what's the largest whole number less than 15 that's divisible by 4? And that's 12, right? So it'll be the fourth root of y to the 12th times the fourth root of y. Now you got to be careful. 12 plus what's 15? When you multiply like bases, you add exponents. 12 plus 3 is 15. And so now this right here is 6. So I get 6 x cubed. The fourth root of y to the 12th, y to the 12th divided by 4 is 3, so that's y cubed, right? And then times the fourth root of y cubed. I cannot simplify that because the exponent 3 is less than the index. And there's your answer. That's the answer right here. 6x cubed y cubed times the fourth root of y cubed. All right, so that's number 10. Now, in number 11, you're given these expressions written with rational exponents, and you want to first of all write this as a radical expression. And then you want to simplify your answer. So remember, as a radical expression, the exponent of 1/3 means cube root. So as a cube root of x to the 12th, y to the 15th. And now these are very similar to those now. So 12 divided by 3 is what's that, 4? So x to the 4th. And then a cube root of y to the 15th. 15 divided by 3 is y to the 5th. Okay, over here, exponent 1/2 is a square root. So remember the numerator is your exponent. So that's just 1 though. And then your denominator is your index. So my index is 2. So square root. So 25 x to the 4th divided by 9 y to the 6th. The square root of 25 is 5, and the square root of x to the 4th is x squared, so that's 5x squared. The square root of 9 is 3, and the square root of y to the 6th is y cubed. So there's the answer there. Now again, just like we talked about, the denominator is your index, your numerator is your exponent. So as a radical expression, you're going to say the cube root, just like this, of x to the 6th, y to the 9th, all being raised to the second power, because the exponent's 2. Here you didn't have to put that raised to the first power because it's the same thing. Now you're going to simplify what's in parentheses first. The cube root of x to the 9th is x squared. 6 divided by 3 is 2. And the cube root of y to the 9th is y cubed. But remember, you are squaring that. So you got to simplify this. X squared raised to the second power. Remember that you can think of it one of several ways. When you have a power raised to power, you multiply those exponents, or you could think of this as x squared y cubed times itself, right? It doesn't matter. You get the same answer. When you multiply like bases, you add exponents. 2 plus 2 is 4. Multiply like bases, y cubed times y cubed is y to the 6th. You add exponents. Over here, when you do it like this, you have a power raised to power. 2 times 2 is 4. 3 times 2 is 6. Same thing. So you get the same answer. So that's x to the 4th, y to the 6th. Okay, so that's going to go here though. This is this, and then there's your answer. Okay, and then number 12, you want to add or subtract as indicated. So you want to look, now these are all square roots right here, so you want to look for perfect squares that could possibly go into these into these radicands. So if you look at 8, the largest perfect square that goes into 8 is 2. So I can write this as 3 times the square root of 4 times the square root of 2. I said 2, I meant to say 8, 4. The largest perfect square that goes into 8 is 4. All right, so 4 times 2 is 8. Over here, the largest perfect square that goes into 32 is 16. So it'll be minus 2, square root of 16, square root of 2. 16 times 2 is 32. Over here, the largest perfect square that goes into 18 is 9. So it'll be plus 5, square root of 9, square root of 2. 9 times 2 is 18. Now I'm going to simplify each of these. The square root of 4 I can simplify. Square root of 16 I can simplify. And the square root of 9 I can simplify. So this becomes 3 times 2 square root of 2 minus 2 times 4 square root of 2 plus 5 times 3 square root of 2, right? And 3 times 2 is 6, so this is 6 square root of 2. 2 times 4 is 8, so that's minus 8 square root of 2. 5 times 3 is 15, so that's 15 square root of 2. What I want you to notice, though, is that all of these terms are like terms. They all have the square root of 2 in them. And so 6 square root of 2's minus 8 of them. Y'all agree that's a negative 2 square root of 2? And then a negative 2 square root of 2 plus 15 square root of 2. Negative 2 plus 15 is, was that 13? So I get 13 square root of 2. So there's your work. Okay, work was required. And there's your answer. Okay, so that is the key to test 4.